All right, welcome back to the seventh installment of us building a vacuum tube guitar amplifier from design to plug your guitar in it and rock out. This is going to be the last part of our design phase, and then we will move on to the layout, which is probably my favorite part. That's not true. When I'm feeling lazy and I don't actually want to do work, design is where it's at, I guess. But anywho's, so you'll notice that this schematic looks different, and that is because I made three changes that I will point out, and I also used this was my original rough draft layout. And the reason I did that is because it was a little neater for me. And I thought if you guys wanted to copy that, you could, or go with what we've been doing. That is fine too. Um, I added all the pinout numbers for the tube sockets. You'll see here's where we left off. There's a heater circuit. And then here are the changes. Oh, I didn't mean to move that. Right there. I changed from a standard resistor to a potentiometer from 220K to 250K. Why did I do that? I decided that it would be good to have a master volume. And so I swapped out what probably looked more like that. I swapped out our 220K resistor for a 250K pot. So if you want to make that change, go ahead. You do not have to. Um, I wanted to have more options, and it's a lot of fun also to be able to play at those lower volumes and turn. This here would be a master volume. You could turn this down and turn your gain all the way up and have yourself some fuzz at a quieter volume, or you can really dial in a tone at a different rate with this. So it gives you just a little more control. And then I want to talk about this. I added a grid stop resistor and an input right here. This is the input section. Now, you could easily overlook this and say, all right, it's an input section. We got a grid resistor over here, which acts the same as this resistor, except it's static. You can't adjust it. And we know we always use 1 meg for 12AX7s. Just FYI, I'm going to use a 6N2P, which is the Russian equivalent of a 12AX7. The heater section gets wired slightly different, so we'll cover that when we build the amplifier, because I'll do both the 12AX7 and the 6N2P. But here we have a grid stop resistor and the input. This is the point between these two that our guitar signal meets our chassis that the amplifier is built into. And this grid stop resistor has multiple functions that it performs. One, you plug in your jack, your tip into the female jack here, and your signal is introduced to a big metal chassis that's vulnerable to all kinds of noises and what have you not. And that is stopped by this grid stop resistor. This helps keep noises at bay. Also, there is something called the Miller effect, which I am not going to go into details, but there are intercapacitances in these electrodes here between the plate and the grid and the grid and the cathode. And those little tiny capacitances, they have a profound effect on noises and frequencies. So using this grid stop resistor, we also get, as a bonus, a high pass filter. So how do I determine 68K? So this is my basic for any 12AX7, 6N2P. I always use 68K, and that gives me the frequency range that I like. Now, if you've played a vintage guitar and it sounded a little too muddy for you and you want to brighten it up a little, you could lower this to a modern grid stop value of 56K. That brightens it up a little bit. I feel like in some amplifiers it's too harsh for me. I like the 68K, gives it a little more vintage sound. And if 56K isn't bright enough for you, you could probably go all the way down to 22K. And then it'll be really bright. But I should warn you that if you go too low in the resistance, it might sound a little plastic and hollow. You'll lose some of those good mid tones. Where 68K, that's my mid, that's my best bet. So I'm not going to get into the calculations for the Miller effect, but you can look that up if you want. And there's a formula where you can plug in numbers and figure out which frequency that you want. But for me, it's 68K. And this obviously this is just our grid. This is our grid resistor right here, and it is the same for 12AX7 6N2P. It's always going to be 1 meg, same as our potentiometer 1 meg. If you want, you can use a 470K or 500K. There will not be that much of a difference, but I think 1 meg gives us our biggest bang for our buck. And then I've added our transformer manufacturer numbers in here so you can see that. And all the pinout numbers are there. I don't think I'm missing anything, but if you have any questions, please let me know. This will conclude our design phase, and we will move next on to the layout, and I will show you how I do that. I do want to show you one more thing, actually. So if you're using microcap, you can go to File, Translate, and go to Bill of Materials and hit OK a bunch of times. A whole bunch of times. Holy smokes. And just keep hitting OK until you get to this. Here is your bill of materials. Now, I have already gone and ordered, too, a bill of materials through Mauser. Let's look at that real quick. Here it is, my cart. And I'm going to make this available. I don't know if I can make a link because I think the link only has so much time. But I ordered all these parts. This is everything on it to build this amplifier. Here's the price. This is the subtotal. I think that's without taxes. I think it was 150 some odd dollars. And that builds the amp head. There's the chassis, the power transformer, power cord, dial indicators. So what you'll need after that is you will need to build a cabinet with a speaker, but we'll get into that. So you're also going to need some hardware to build this that isn't included. But the best way to do that, go to Lowe's, go to your hardware store, get a whole bunch of 832 screws, lock washers, and nuts, and that's all you're going to need. But anyways, let me know if you have any questions. It sure has been fun designing this. Let's get to the build section and let's knock this amplifier out of the park. I will put up that bill of materials as soon as I confident that it's good. And because I don't want people to buy it and then it have stuff that's wrong, or I don't want anybody to lose any money because that would suck. So I'll go ahead and take the hit and make sure that we got this right before we go. But when I know it's right, and it'll probably be after I've built and tested the amplifier, then I'll release the parts, and we'll be able to go ahead from there. All right. Thank you so much. Let me know if you have any questions, and have a great day.